Alright, this is how all started. Here is obviously I started already, but I wasn't unsure how I will fit it in the final design. Um, so this is a sketch that I made it in Photoshop. So these are some ideas. Here is some ideas. This is an idea. This is another idea, and this is another idea. And then I said, well, then I made this idea here, and I said I like it. It's simple, is practical. And then I made this one, and then this one, and then this one, and finally I get to this one. And then I tried something else, but I didn't like it here. So I got back to this part here, and I had to convert this flipping. You see here in the middle is bending, and I had to find a way to flip it on the other side of this circuit under the display, the circle display here. So I started already, but I didn't made too much. I only made exactly what you are seeing here in the picture. I didn't added the potentiometer. I probably, if I remember right, at this stage I've added a wire, and the potentiometer was probably from these two wires that you can barely see here. These white wires, I believe it was here. It was the potentiometer, and so basically it was staying in air, and I was turning it and checking if everything is correct. So I started with making this flower LEDs shapes, and then I added the circuit on in the continuation of it, and I probably I had the idea to bend it, the circuit, to bend it under the flower display from the very beginning. I'm not completely sure what I was thinking when I started everything. I only wanted to test how nice it will look with a flower display like this, and I like it. And then I said, well, I have to make a design for a complete device that you are seeing it here. This is the final design, what you are seeing here. And I follow it, but you'll see it will not look as good as in the sketch, unfortunately. I will probably try in the future to make it as good looking as here in the sketch, but we will see. So now I'm making this movie after I finished everything, so now I have to remember what the fuck I was thinking back then. So I followed this design structure that I envision, but not really 100%. And as you can see, I was thinking I will have two wires here, actually, one for external clocking, one for internal clocking probably. And in the end, I believe I left it with only one in exactly like it is right here. I probably no. This is the internal clocking here, and this is the external when you can press the button. Here is the button here, and so this is the reset button. This is the +1 button, and these are the switches here, and this is the beeper in the middle, and this is the speed. And here I was thinking only to receive. This is an input, I believe, or external to. Yeah, I'm not completely sure what I was thinking. If the arrow is pointing outwards, probably I was getting the signal that I'm creating with this device and powering something and clocking something else. Probably that was the idea I was thinking when I designed this little user interface that you're seeing here. It's looking very, very nice here. Not so nice in reality, but it's close. I mean, it's close enough, you know. All right, that's it. All right, I just made these boards here. These three boards. I bended this element, this composite, and these are the wires for the potentiometer that I'm having here. I actually started to make the circuit diagram exactly what I'm having here. The idea, it came to me a bit late, but today I make it. And this is 7414 NOT gate, this element here, which is this little package, and you can see it here. There's this little black thing there that I'm pointing at, and this is 4017, which is this one here, and all the links that are going there. And right now at this stage, I just mounted columns. This is a column, this is another column, and this is another column. This column here is for the potentiometer, this column is for the button, and this is also for the button. And I wanted to, I just finished making them, and I was thinking maybe it's a good idea to make the movie. And I moved a little bit too slow. Now I will film how I will solder this button here, also to be in a line with that button as well. I don't care about the potentiometer, how it's looking. These pads, I can move them around because they are glued, and they are heat based glue. Okay, let's say it's good. I'm also looking here the distance between the button and the potentiometer, and here is a bit too wide, so I'll have to do something about it. I don't know how yet. Or maybe it's
Let's see. The pad is moving. It's actually floating there. I can't do it like that. Probably this is good enough. Okay. So I didn't think this will be too much trouble. Okay, then I will bend this little leg a little bit. Come on, baby. Like that. So I bend it a little bit oblique, and is actually reaching the middle of the pad. There is. Yeah, I will have to also strengthen it to make it. So this is how the soldering part for the component is very easy, and also the pad got away. Unbelievable. You wouldn't predict or imagine I will have so many troubles. I didn't have any trouble here, but here, because I'm filming, that's why. Yeah, it's good enough. It's good enough. Okay, good. Maybe this pad. Or reshape it like this. Come on. Yeah. That's the beauty of having floating pads with glue that is hardening very well, actually, when it's cold. But when it's hot, it's becoming extremely fluid. So it's after it's getting cold, it's getting very hard. Hard like resin hard, like, I don't know, like a very hard rubber, extremely hard rubber, like a cement almost. Okay, so that's it about this element that I'm having here. A lot of problems for this one. And yeah, it's looking closer to my sketch that I made. And as you can observe, everything is made on cardboard and glued. And yeah, it's pretty awesome. Pretty awesome. Of course, these wires are not linked yet, but they will be linked to this potentiometer. All right, I like it. Let me actually show you how it's working. If it's still working after I build it so far. Yeah, it's giving me, Come on, baby. But it was working. Yeah, well, I will have to find the fucker. I didn't connect it to this potentiometer, that's why. That's why it's not working. I'm an idiot. All right, I will film a little bit how I'm making the holes. I already made that one. And how I'm linking the wires. This hole for this, and here. A little bit of hole over here. Yeah, that's good enough. And here. And here. And here. Not to be on the margin. Two on the margin there. Yeah, good enough. So these are my holes. And now I have to link these two wires into those holes. Of course I will change them, because this was temporary here. So I'll do it actually right now. It's a little bit tricky here in the middle of the things. Yeah, that's good. All this, what I'm having here is scrapped wire, copper wire, from diverse bobbins, from a TV bobbin actually. You know those coils on the ray tube? They have a funny shape of like a flower, like that. Those coils, and I scrapped some of these copper wires from that, and they are, you see, they are soldered together. But this is good because I can desolder everything what I'm having here and repurpose it with the solder that is already there. So good for me. You see, it's having multiple wires, and this was an end, and it was around a pin. It was like this, and the wires were coming out from that pin, and I desoldered, like scrapped everything. And this is the cut wire from that pin, you know. And I said, well, it's a good idea because to salvage it, because it's having already that you know, tinned, prepared wire like this one, and I don't have to prepare it myself. That's why it's very convenient. Let's see. Well, yeah, I will have to drag so from here to here and from there to there actually. Are you going to? It's too short. A little bit longer. Yeah, I can use a longer wire and cut it as I need it. It's already prepared, so I don't have to prepare it myself. So that is extra mega good. But is a problem. Ah, yeah, from here to here. Okay, and it will not interfere with anything. Hopefully, it's good enough. And let's see. Okay. Yeah. I'm thinking if I want to use this naked wire that I'm having here, yeah, I can put a piece of paper over it. Yeah, actually, you know what? I'll actually do it. I'll actually solder it here. There. And I will put a piece of paper, I will glue it here over the wire to isolate it, not to move, and to make other contacts, you know. So that's my idea. Yeah, I really love to work like this. It's a very nice feeling when you are building something like this. It's very therapeutic, and yeah, you see, perfect. I really like it. I really like it. Actually, this piece of paper here, this one, is having a tiny little bit of border here, but I don't want to risk it. Yeah, okay. And here I'll bend it like this and glue it there, and that's it. This is the first contact. It's good to have a bit longer wires. So like that, right on the margin there. Perfect. This is what I wanted. So it was a little bit longer. Yeah. This is the best method actually, but I'm not using it all the time. To solder it there, drag the wire to where I need it, and leave exactly what I need here, how much I need it here. I'm not, because I'm using a lot of scrap already cut dimension of the wires, you know. So I'll have to protect this wire from moving around by gluing a tiny little bit of paper there, and like this long, and it's good enough. Huh? Is it only here? And here, yeah, it's good enough. Okay, tiny little bit of paper. I probably cut it a little bit wider than I sketched it, but we will see. This is Lipici de Timbre, it says there. It's a glue for very mild, very, you know, it's extremely good for paper only, but it's not good for anything else than paper. So this is for stamps, like your, you know, those glues for stamps, but it's very watery, full of water, and it's not good for everything. Only paper on paper. Paper on paper is formidable good actually, but like I said, not for everything else. So that's the idea. Come on. Right now it's very slippery, but it will conform with what I'm having there soon enough. Yeah, actually this is the border that I'm having here from this paper, probably. Yeah, so now this paper that I'm putting it here, that I'm gluing it, this little thing is, yeah, like that, is protected from moving around. So I'm constraining it by putting this paper here, and now I'm marking that is something underneath there, you know, like yeah, perfect, I love it. So that's the protection, the insulation, a little bit of paper there, and here let's hope it will not move around and make any other funny business. There is the gap is very close, it's very short there. It should, yeah, it's good enough. It's good enough. It will not go there by itself. Okay, and next wire is from here to there. No, from here to here. It will go like this. So I'm tracing right now. I'm thinking how I will trace it from here to here. So this wire, it must be isolated. Must be an isolated wire. Very conductive. It's not having any kind of isolation, this one, but this one it has. But I'm really not trusting it that much. But it is looking like it's good enough, you know. But I'm not completely 100% trusting it. I believe it was having gaps of in the isolation layer. Hopefully those gaps will not interfere with my thing. The thing is, I can use it because I'm using very small parts of it, you know, and not very long. Usually, I can use very long parts as well, but I don't need it. So, all right, let me prepare it a little bit. Actually, let me bring this. This is a funny story here, very funny. A transistor blew up here. It was a SMD transistor that blew up. Oof. it made a small atomic cloud like that. Okie dokie. Okay, so I'll do exactly what I did there. Again, I'm not doing it like this every day, but in specific circumstances like this one, this is a very specific and very, yeah, I really need it to be perfect length with no bullshit. So there, until, so yeah, the idea is that this wire will go like this, next to this one, very close to this, and going into that hole. So I'll cut it from here, like that. Actually, I should have leave it a little bit longer to have a little bit more flexibility, not to be exact. Let's hope it's good enough. Let me actually prepare it first. Yeah, I was a little bit too exact right now, but it's good. Is this the perfect length and the perfect, yeah, it can wiggle a little bit. I need it to have a little bit of wiggle room, not to be perfect. Yeah, it's good enough. It's good enough. It's in margin here, but it's having a good contact length, even if it's on the margin. And now it's under a big blob of solder here, and this is it. Now it should work fine. Let me test it. Okay. And I did not work. Fucking hell. I hope I link it. Okay, well. It's not clocking because something here got destroyed in the building process probably. Let's be sure it's not this wire here. Yeah, probably. Let's see. I have no idea what. So this LED should blink here. Usually it's this little shit. Probably, I believe this resistor probably is having some soldering problems here. No, it is not. Or in this other side. No, it is not. Motherfucker. I did press a lot here. Maybe I didn't make the contact correct? No, I think I did. What was here? Motherfucker. When I'm filming, and here it is how it's working. I had quite some problems. The potentiometer here was the problem. And because of it, until I discovered it is the potentiometer, I actually changed the 7414, the NOT gate, this little fucker there. I changed it, and I have it there. That's the fucker that was before, and probably it's good, that other one, because the problem seems to be from this potentiometer. So I might have change a new one with another new one. So that one probably was good. And of course I made a little bit of changes here, the wire, and also I've added this pad. It's a margin pad. So this pad here to link two pins at once. Let me show you here. This not connect, this is a C there. So not connect pin and this input pin together, and I made a pad for them. Before I was having a wire, and actually this is the second, this is the third NOT gate that I'm having here, and the second replacement, because the first one that I had, I managed to rip off one of or both of the pins, because I was having a wire, this one of these copper wires, you see them here, probably, you see this orange copper wire here, it was linked directly to the pins of it, but now I've added a pad and I press it, just press it there, and then I soldered those two pins together onto this pad, and the wire, the copper wire, is not on the pins directly, is on this pad now. So this is this is a little bit of change that I just made with this occasion when I changed this this is the third NOT gate, and also I changed this red wire because the other one was the isolation was melted very close to this very important not to touch and not to short areas. And then after I managed to make it blip and work, it worked for a little bit, and then it didn't work. It was giving me the same behavior like before, and I just poked around. Literally, I'm poking like this, and and I managed to find out that this motherfucker potentiometer, which is in this circuit here, for this little clock to work, this resistor must be active. It must contain a resistor there, and this potentiometer didn't. So I had to switch. So this leg was busted, and I measured it with my multimeter from there to there, and it's nothing. It's showing me like is open circuit is nothing, no resistor. So something, my believe, probably when I soldered the wire underneath this wire here, when I soldered its end to this pad here, most probably I overheated the leg of the potentiometer before. And now when I reheated this leg, it got busted. Something broke internally in the plastic. Probably the plastic melted, and it is not making a proper connection. And I'm glad that is this leg and not that common leg there. And literally, I because these pads are glued here, I move it. I heat it up and move it on the other leg. And I also check it. And from here to here, I am having a connection. And I check it with my multimeter here, but when I solder it here, it gives me the same issue. So probably something is very weakened here, the plastic probably. So I resolder it again, and I move the potentiometer a little bit for the legs to move, in the hope the legs will move inside the potentiometer a little bit and make some contact, is what I imagined. And I was right. Something is fucked up inside this potentiometer, and this potentiometer is brand new actually. It's not a scrapped one. So I definitely overheat like an idiot the leg, at least this leg, because it's absolutely no connection now. And from this it gave me a little bit of trouble, but now it seems to be okay. I'm not trusting it 100%, but well, if it will not work in the future, I will know this potentiometer will be the most probable cause, because I'm pressing on it all the time when I'm changing it, the speed. And after I managed to fix this problem with the potentiometer, this motherfucker, this LED number 3 here, didn't lit up. Sometimes it was lighting up, sometimes it was not. It's because of this bend that I made here. You see, I bended this, and I actually pressed it very hard, and I use my tweezers. I put my tweezers like this in between these two pieces of cardboard, and I pressed to make a larger bend there, and it broke. And this is the little wire, you see, the little fucker, and the other piece of wire I put it there already because it was a little bit longer, and I literally had to drag it out from this part, from this side, and then I inserted a new one, and I remade the connection, and now it's working perfectly. So let me show you when I'm turning the potentiometer here. You see, it's working very fast, and I deliberately, this is the slowest possible, the minimum speed that is getting with this 500 kilo potentiometer. I was lucky to have this 500 kilo batch. I'm usually not using this high value potentiometers, but in this particular case is the single batch of new potentiometers, and I have only 10 of them that I was having on this value, 500 kilo. And yes, it's working perfectly fine now, as it was working when I was testing it actually. And a lot of problems when I make it here, when I make it to be standalone like it is right now, the final product. Okay. So at this side, it will jump. So I have to move it very fine here, because it's jumping in speed very quickly. But the rest of the travel of the potentiometer here is like 80% of it is moving slowly. In the last 20% or 15% like that, is jumping very fast. You know, and I have to tweak it with care here, very carefully, what speed I want. You know, it's already jumping like crazy, but it is manageable actually. Yeah, I'm very glad. And this will be a reset, and this will be a step button. They are not connected yet. They are only glued here. Literally, they are glued, the pads, and well, it's soldered. I realized that in between these two buttons, I realized that I can actually move this potentiometer left and right to center it between these two when I had this problem to resolve it. So yeah, well, little shitty lessons that you never want to learn them. Yeah, this is called experience. And why I'm showing you these problems is that when you are making something, shit will fucking happen. So trust me, shit will happen, and the only good mentality is to resolve the shit and to understand that it is a little bit of shit that you didn't expect it, but you must understand that it will happen. And if you know it will happen, you switch gears and resolve the problem. When the shit is happening, you resolve it. You find a way, like with that little shit with that little lead problem. It's a little shit, and you have to stop from everything and concentrate only on that problem and resolve it, and that's it. Find the fucker. And this was actually very hard to find, this potentiometer, very, very hard. Like I said, I had to change that chip there, and then I find out that it was giving me the same results like before, and then I find out it's actually this motherfucker here. Yeah, unbelievable, unbelievable. This is a big shit here problem. Bigger problem it was with this potentiometer, but I'm happy it's working okay now. Although most probably I damaged it quite good, this potentiometer, for some reason. I usually, yeah, probably I overstayed, I overflowed these legs, or these potentiometers are a bit too sensitive. Who knows? Who knows? The plastic in them, yeah. But I really like them. I really like them. They are very good actually, when they are not overheated. Okay. Yeah, I'm happy that is working okay. Next, I will have to add these two buttons, and see you next time. All right, I managed to link this reset button to make it operational. So now, when I'm pressing reset, it's resetting to 0 there every time. Isn't it gorgeous? Excellent. Back. Like, especially this reset button is especially good when it's a slow clock like this. When it's a very slow clock, and you want to I made this reset button specifically because I will count manually from this button. When I will switch this button, it will count one by one, and not automatically like it is right now. But this right now what we are seeing here is a piece of the circuit. The entire circuit I will have to add some other stuff to actually switch from automatic like it is right now to manual or outside impulse clock. It will be the same thing, and I will have a switch there, and also another switch here for a beeper. I'm not completely sure how I will make the beeper, but that's the intention at least. But until then, I managed to make this reset button that is functioning absolutely fine. Let me show you the other side. Usually I can maneuver all this with it in power, but this alligator clips are gripping so hard on the wires that the wires are literally twisting, and I don't want to have some pads get off from what I'm having there. By the way, this first of all, the links, and here it is. This is the link here that is going exactly on this pin, on this exactly on this reset pin, and this reset pin is actually having a resistor here 10 kilo to the ground all the time, and when it's receiving a positive, it is resetting, and the positive is this wire, red wire that you are seeing here, that is coming from this side, is linked there to this positive rail onto this side here, and is actually making the connection between that positive rail there to the pin of the chip. And that's the whole philosophy about resetting. Is that simple. It is that simple to create a reset button. If you didn't know, just add a positive rail and that's it. And it's resetting. Very cute, very, very cute. About this chip, this is a bad chip. It says there with barely visible with red, B, bad, it says there, because this actually was in another circuit and it was bad, but when I mounted it here, I was expecting it not to work correctly. I really literally was expecting it to be faulty, to some outputs not to work properly, but I linked everything nevertheless, and after I link everything and I made it, I see that this chip worked actually correctly. And my suspicion in the other circuit that I was having it, I believe it was not working because, or the reset pin was on one output somewhere and is making a conflict, because the rest of the chip is absolutely fine. Unbelievable, really unbelievable. And it got damaged, it got fucked up in the other circuit that I took it out from. It was a long time ago, so I don't remember what was doing exactly, what was the problem. But I have a movie with it when I took it out from that circuit. But that's the thing is apparently it was bad, but now when I tested it here in this circuit, is working absolutely fine. Unbelievable. I really don't know what might be the problem. I really don't know. My suspicion is this carry out, because it's not related to anything else. Probably I can actually test if it's this, but or the reset pin. linked to, probably I was having only 4 or a couple of counting and then resetting, and probably this maneuver linking the reset pin to one of the outputs, probably that's the faulty element in this chip, in this particular chip that I'm having here. Is my suspicion, is what I'm thinking it might be. But be aware. So I'm showing you this because I'm using fucked up chip that apparently is working fine, but it didn't. And another fucked up component, which is this potentiometer, that I fucked it up now when I was mounting it here. Yeah, unbelievable. And I managed to make the second function of this entire device that I'm building here. So the first function is auto incrementing like that, and the second function is this button. Pack. When I'm pressing, the button is incrementing by 1, and if I'm holding it, it's not doing anything. And you see, sometimes it's skipping, but like 95% is listening, is doing exactly what I wanted to do. So let me show you the circuit. Yeah, well, I can show it here. I use the button debouncer using another 7414. The first 7414 is used for the flip-flop, the blue LED that is auto-incrementing there. You see, if I'm switching to that mode, it's auto-incrementing with the 7414. And this time I use another 7414 for the debouncer, for the button. And this is the entire circuit that I'm having there. So as you can see, I erased a lot here of circuit because initially I linked it without this button debouncer. Although I was very aware it will do some funny business, and it did. When I was pressing the button, it was jumping, and I didn't film it like that because I was very skeptical if I will fit. That was the main problem that I had, if I will fit the circuit. And I managed to find a very clever solution, actually. Let me show you. I will stop it and I will show you on this other side. So unfortunately there are a lot of wires now than before, and this is the debouncer circuit. It's only this little circuit board there that is doing exactly this. Is having all these 3 components: 1 resistor, not gate, and 1 capacitor, and the button is on the other side, and the wires are going to it. But for this little board that you see here is only absolutely 3 components, and I managed to link them between them very cleverly, actually, because if you can follow, I'm not sure how to show you like that. So I switch it. This is the 2 pins. This is the positive here, and let me zoom out. So this is the plus 5 volts, which is this pin. On this side is having 3 pins. This is not connected, the first one. And the second one is the input. So I link them together pretty much. I made a cross here. I cut the copper in a cross, and I have 4 pads. And each pad, I actually have a sketch. I don't have it. Yeah. This was the preliminary sketch. So I'm having 4 pads. 1 pad here for this 2, another pad for the positive pin there, and another pad here, and another pad here for the negative. You see it here. This was preliminary. This was the original sketch. But then I thought on using this. I actually started to make. Where are you? I started to make this particular circuit on this board, but then I had problems here in the intersection. The gaps must be extremely small, and it's not. I thought I must find another solution, and I did find this solution with this board. Let me actually show you the boards. Here they are. These are uncut boards, and these are cut boards. These boards that I'm having and that I'm making them manually myself are for SMD transistors, and I managed to adapt. Let me actually show you. So you see, it's already cut in 3 for a transistor here. What I did, I cut it. I made a cut here, another cut here. Like that. So I continued this cut from there, and basically I made 4 pads. And what I did, I united these 2. I actually bent this pin towards this not connected one, and I made a 4 pins device pretty much on this little pad. And as you can see here on the diagram, this 10 kilo is linked to the plus 5 volts, and here there is the 10 kilo. You can barely see it under this white wire, but it is. You see it there? There it is. This is the capacitor to the ground, and this is the link to the ground here, to the ground of this chip, to the 4017 chip. and another wire, the ground wire that is going to the button, and this is the button ground wire that is connected to that capacitor, and that capacitor instead is linked, this pad is linked to this wire here, is a common negative here, and this is the output. As you can see, this is the output pin there, and it's going to the switch, directly to the switch. You can follow this white wire is going to the switch, the output, and this is the output here, and then two wire here on the input is this pad here, and I collected from there. This is the pad, and I collected the wire and is going directly to the button, and one other wire of the button is going to the negative here. So this is the entire circuit made on a single square pad here, and it's glued. Everything is glued. I put another cardboard underneath to be on the same level with this other cardboard that I'm having it a little bit raised up. So I was thinking to use a single line, but then I bend it, a single wire, but a straight wire like that. But then I find another one that I bend it, and that's it, and that's all. That's it, and that's all. So pretty much this is the circuit for the debouncer. Let me remind you again. So this is the debouncer circuit, which is this, and here is the a stable flip-flop, the pulsing here. This circuit is in this part here, and this is the actual the entire circuit board, the entire circuit that I'm having here. I know it's a little bit complicated, and as you can see, I'm adding and I'm progressing and I'm developing this board. I'm adding to it and I'm taking out and I'm adding new stuff, more complicated stuff, and I'm struggling with space. And yeah, it's and I had a ton of errors. You wouldn't believe it, how many errors I had, and I had to resolve them all back to normal, like it is running now. The main problem I had was this potentiometer that for some reason it didn't behave very well after I overheated its internal structure, and is going nuts a little bit. I'm very happy for the 4017. That is actually, it's a bad chip from another circuit that I had, and I put it back here, and I'm very happy that it's actually working exemplarily. This 7414, so this 7414 that I'm having here for the debouncer, for the button, was actually here when I replaced this, before I understood that I had the problem on the potentiometer. I replaced this chip with a brand new here. There it is. And this I put it in the garbage bin, and my garbage bin is this. It's very easy. It's very easy to get back to it and collect if I changed my mind. Usually I'm not putting it directly on the garbage bin. I'm putting it aside here, and then I changed my mind and I took it out from there. So in the same time, this was actually a test if this component was working, and I actually wired everything. I didn't glue it directly like it is right now here. I wired everything. I was having the board here. I wired it very quickly. I powered it, and I put the oscilloscope on its output, and with another wire I was touching the negative rail to probe, to test if it's doing the thing, if the chip is good. That's what I was doing. I was testing the chip, and it did behave okay. I got sometimes I got a very fast a little bit of error, like 1 or 2 pulses that it shouldn't have been, but overall, like it is right now, it was doing the good thing, the right thing. And I said, well, this chip is actually good, so I was confident to actually implement it, to put it here on the final design, on the final board. So that's the history how I build it. So yeah, very, very tricky and very hard to do it. Very hard to do it actually, because of all the wiring that I'm having there. And I'm having a little bit more of this circuit to add, but so far at this stage as it is right now, I'm very happy with the results that I'm getting from it. It's very interesting. It's very interesting. I like it. Let me power it again. Yeah, it's doing this error a little bit when it's starting, but it's fine. So this is continuous auto clocking, and is actually variable, like you already know. You see, so it's a variable auto clocking that is doing by itself. When I'm switching here, yeah, I'm having probably some. It is this motherfucker. This is doing some stuff. Yeah. Come on. Yeah, you see? And it's working absolutely perfectly. Sometimes I'm getting 1 or 2 problematic inputs, but very rarely. Very rarely. Usually it's working fine on the press. Come on. There. I might have to change this potentiometer because it's giving me a ton of errors. And yeah. This LED, this pulsing LED that I'm having here on the back, this is actually clocking and working all the time, and I want to change that behavior, that LED, depending on the switch that I'm having here. If I'm switching this to auto or to manual here, to actually blink the LED when the actual signal is going on the clock pin of the 4017, pretty much. Yeah, I'm having a little bit of problems, and I bet I believe is this motherfucker potentiometer that is doing something weird. I'm not sure what or why. Yeah, you see, when I'm pressing it, it's doing funny stuff. Oh, yeah, I actually replaced this potentiometer with a 10 kilo here, and I was having a constant and not variable movement here. And when I was switching, I wasn't having this kind of problems like I'm doing that I'm having right now. You see, when I'm moving it, is behaving incorrectly. But I will solve it because I know exactly the problem is this motherfucker. I will keep it here for the moment, in the hope it will behave. But in the very end, when I will finish everything, I will actually I will actually replace this motherfucker and with a brand new one. It's a pity that I destroyed it. I'm very my heart is crying right now after it. So yes, no, I really I don't like when I'm fucking up a brand new component that I'm having. I really don't like it. The next thing is to add this blinking LED that I'm having here, the blue LED that is blinking there, here on the top to correspond with the actual function that is switched here. And then I want to add, this is the final module actually, a beeper to beep corresponding in correspondence with the changing LED that I'm having there, and an on-off switch. So it will be in parallel here. I already find a little buzzer. This is it is scrapped, and most probably it is scrapped from a cellular mobile phone. Most probably, I'm not sure, but I know for sure it is scrapped. And I really like this very tiny, very buzzer, very interesting buzzer. And I have no idea at what voltage is working. I have absolutely no idea. I tested it at 5 volts, and it was a little bit hard. I could hear how it was kind of stressing. I only made some beep 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 beep, very short blips, and then I decided to add some resistors, and after some testing I had to get down to 10 ohms here, and at 10 with that 10 ohms is not so hard. Is at 5 volts is running medium. The sound is not too high, not too low, and I trust it's good enough with that 10 resistor. So this will be the next step, adding this buzzer here. And the button for switching the buzzer on and off if I want it to beep or not to beep. And after that, project is finished pretty much, and then the case, and that's it. Yeah, actually I prepared the button for the on-off switch for the buzzer. Here it is. It's a little board, and this is how it's looking on a cardboard, of course, with little pads that I'm making, and that's it. It's exactly the same as this one is. Its brother, and it will stay in this position like this, in this other side, and the buzzer will stay in the middle there, like that. This is how it. This is the setup. This is how it will be in the end. I really hope it will work like that. Already I'm having a ton of wires underneath it, and yeah, these wires are not nice. They are pretty ugly. I left the entire length of the wire. I didn't cut them to the exact size, so that's why it's looking so wobbly there. I probably should cut them to size, but later when I will finish the project. That's the cleanup, you know. All right, I managed to make the clock LED. In the same time, you see, it's the blue one is on this other side, and you can see the blue one that is there on the paper. So this is a clock LED. Right now it's showing the clocking that is running, auto running here. And if I'm switching to manual, to this button here, you see, when I'm pressing, it's showing the correct clock pulse that is generated by my finger here, by my button that I'm pressing right now. And when I'm switching to automatic, and also when I'm when I'm turning the speed down, if I can do it with one hand, yeah, you see, is in accordance exactly with the clock speed. It's actually inversed by this other one because that LED was here, and you can see it's erased. This 10 kilo on this LED was here in this circuit diagram that I'm having, but I actually left it. That blue LED is the original that was here, and I erase it and I switch it. So I turn it to this middle line that is going directly to the clock pin of this chip. This from the switch. This is the switch. You can see there SW. It means the switch, and the middle pin of it. I linked this LED and it's a 10 kilo resistor exactly to that line. And when I'm switching from automatic here or from the button pressed circuit, is connecting these two lines or these two lines, and is lighting accordingly this LED. But I didn't do it like this here because I had to drag a very long wire diagonally through the entire circuit. So I chose the negative pad that I'm having here, this is the negative pad. So instead of this LED being linked to the positive like in this diagram, it is linked actually to the negative rail. And so the current is surging through this resistor, through the LED, and into the negative pad that I'm having here. That's what it's doing. And this is actually more correct than this other blue one. This blue one from the positive is inversed. I don't know how to say it, but it is lighting when after the pulse occurred, not when the pulse is occurring. So it's a difference. It's exactly when it's rising up, the pulse, and staying up, this LED, this green LED is lighting up. But when it's down, is this LED, blue LED. I don't know how to explain it better than this, but this is a bit counterintuitive how it's lighting in accordance with this thing. But this is in accordance with this. You know, you can see when it's raising here on or high, it's switching there, but it's not the same with the blue one. Although I leave them both, they are performing the same task, and but one is inversed from the other. That's the only difference, but it's performing the exactly same function. And yeah, that's it. That's pretty much that's it. So imagine I'm having this resistor and this LED, but instead of being put to the positive, here is actually a negative rail, and that's it. This was a very hard design problem because I want to maintain a certain size of this thing. As you can see, I can hold it in my fingers, and it's long as my finger, half of my finger here, as long, and also the width I wanted to maintain it, and I couldn't actually decide where to mount this LED because I don't have that much space design-wise, and I have to leave this space here for the beeper. There, here, this is the beeper, and it's a corresponding switch here. So this is the space designated for this thing, and yeah, I'm not completely sure how it will fit everything in the very end. I will make probably some other tweaks. But so far, so good. I really like it. I really like the design and the idea of this flower circle moving LEDs. It's very cool and very neat design. I love it. I love it. And I also was thinking if I want to count something from an external source, I can actually link this wire here from an external source from outside. Instead of pressing this button, this point, which is this pad here, will get the external pulse and will count what I'm clocking from outside. So it's the same with the button pretty much, but the button will not be pressed, but instead listen to the outside pulse. So it's a 2-in-1 function, this pad, you know, one for the LED and one for the pulse, external pulse. So it's a very cool idea. And also this LED is showing me the exact pulse that is coming from anywhere. So it's a very neat function what I'm having here on the front of the interface of the device, in the front of the device, to actually see what is going on, compared with that one that is on the back. So far, what I built here, I didn't get any kind of help. It was very straightforward, very intuitive to make it. And one very, very extremely important thing I forget to mention in other videos until now, is that this entire device is built around one single chip, this 4017, that is doing all this magic stuff that is you are seeing there. So this is the brain, the core brain, and this is actually this is a miniature computer, a very basic function computer, what you are seeing, with only one logic chip. And it's interesting. It's interesting, you know. The usage of it, I have no idea where and how to use it yet. But I really like the design of it. I really like it. It's looking ugly on cardboard and like a prototype. But as it is looking like this, I really don't mind. All that I care is not to break it, because it's very fragile and sensitive, and yeah, and a lot of components, a lot of solders that can break and make my life a hell, a living hell to find. That's the only issue with this kind of design. But other than that, the design is very, very cool. I'm very happy that I got very close to the sketch that I made, and most probably I will continue it to finalize it in that direction of the sketch that I made. All right, I hope you like it as I like it, and yeah, very, very cool function that I managed to implement here. And I'm almost done. I will or I will not. Probably I will. I am 50-50 with this beeper, if I will implement it or I will not, or I will give up on it. So right now at this stage, I am 50% giving up on it. I'm considering to give up on it, not to implement it. But I will also try it. All right, ladies and gentlemen, here is a setup. This is a preparation. This is a test actually, because I really don't know how to make this beeper. I actually made one beeper, but it was weird. I have it there on my other project that I built there. and this is the beeper section of it, but it's weird. And now theoretically I'm more close to something better, hopefully. We will see. We will see. So I'm having here a normal chip, a deep chip, 7414 Schmitt-Trigger NOT gate with 6 gates in it. You can see it here. 7414 is the same pinout like the 04. That's why I'm having both of them, and both of them are NOT gates. The only exception, this is different a little bit, Schmitt-Trigger, which is doing all the stuff. So I connected the input here and the output here. Actually, I used this other gate I connected the output from here to the input to this, and I collected the output from here. You will see why in a second. When this green LED is, let me show you like this, if I can. If the green LED there is getting on, I'm getting a positive spike. The time this is staying off is going to the negative rail on the bottom there. That's so this is the setup for the beeper. Here I put an electrolytic just to see if it's working with an electrolytic, but I don't have to use an electrolytic. I can use, I actually tested with a solid capacitor, and it's working absolutely fine with either types of capacitor. So it doesn't matter what I'm testing here, what I'm using for the capacitor. So it's okay. So now let me, so this is slow and this is very slow. So you see the positive. So what I did here, what I built here is this little thing. I didn't make it on this final circuit because right now I'm testing. So this is the circuit that you are seeing here, positive edge detector for this, using this 7414. It's very simple. Is getting a signal from here into this capacitor here with a resistor to the negative rail into the input of this NOT gate, and then you collect the output. Pretty much that's it. I needed this 10 kilo here because let me show you what is happening. If I'm connecting it directly to the output of that, so if I'm connecting it directly, the probe, at least this probe from the oscilloscope, if I'm connecting it directly on the output of this NOT gate, is interfering. It's only the output here. It's not the input. It's very strange. So it's feedbacking, is transmitting something back probably somehow. And if I'm disconnecting the output, everything is going to normal here in this circuit. So I had to play around for a while to find a proper solution, and I did find it, and is with a 10 kilo. So from the output there, a 10 kilo, and that's it, to the at least to this probe that I'm having here. Let me show you the output. So the first output, exactly like in the circuit here, exactly like here. Let me show you how it's doing. If it's staying there like that. So now it's running fine. So you see it's inverse. It's staying on positive and is getting a spike to the negative. But because it's passing, the signal is passing through this gate, NOT gate, and is inverted. So to have the correct signal pulse, if you like. So pretty much right now what it's doing is beeping all the time. If I'm connecting a beeper, it will beep all the time, and only a fraction like that, a zip, like a spike of not beeping. So this is not correct. So I have to add another NOT gate there. So I will put this resistor to the second NOT gate. I'll make the diagram and it will be very easy to understand after that. So I'm connecting it to the next NOT gate, and I'm getting the correct output. So now it will, my beeper will beep when the spike, positive spike, is activated. And I can enlarge this the base of the spike and the top of the spike, actually the entire square. It is a square wave, but it's like a spike, and I can enlarge it very easily. Actually, I did my homework. I did the tests, and here it is, 100 kilo. So I tested it with 100 kilo instead of this 10 kilo that I'm having here. And here it is on the input, the negative probably. Yeah, and you see that it's getting a wider square wave impulse. So it's I can actually tweak from the resistor and from the capacitor how long my beeper will sound, pretty much. And I only want a very short beep, like beep beep beep. And as fast as I'm going, let me take it back, replace it back as it was on input, I believe, yes, to the negative, like that. So it's the same. I want this signal, the beep, to be very short, like beep, 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 very, very short. So now it's very slow here. It's running very slow. And now when I'm rotating it and making it faster and faster, you can see there, it will practically it will sound all the time. It will make a or like that, and the beeper. Yeah, probably in the movie this LEDs are not showing very well, but they are lit, all of them they are lit right now, but they are running all the time. So I'm not sure if you can see. I don't know. It's the frame rate probably, but they are running very, very fast, all of them. Let me, no. So yeah, the camera is, but trust me, they are flickering all of them in the same time right now. The speed is very high. So I cannot, kind of. It's kind of catching something, but yeah. So the idea is to get a train of beeping or like a bazinga of the beeper, you know. So that's my okay, slow it down. So the beep, 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 beep. This is what it should do. This is the, and I believe it's good enough. I believe it's good enough. What I'm having here for the beeper. The next thing to do is to actually connect the beeper and to run it and see what's happening. That's it. For now, for the moment, I only oscilloscoped it. It's it's good to see the width of the signal. It's very interesting to see it on the oscilloscope. All right. Thank you very much. All right. And this is alive. It's alive. I managed to burn this. It appears it's not working at 5 volts or 5 volts plus 100 ohms. After I soldered these two wires, it didn't work anymore. Probably I overheated those pads, who knows, but they didn't want it to sing anymore. So I got out active buzzer. There are passive buzzers and there are active buzzers. This active buzzer is having a small board inside it that is making it beep continuously if I'm powering, and it is for 5 volts, and it is as you can see, I scratch it there to know what is what, and it is polarized. I have to not fuck it up. So if I'm plugging it there and there, you see, directly to 5 volts. 5 volts is beeping continuously because it is an active beeper. That's why. If it wasn't an active beeper, it wasn't beeping all the time. So if I'm varying the speed, it will beep exactly as my pulse that I created from there. It's a very very small pulse. You've seen it on oscilloscope. It's like that. And I wonder how is sounding with if I'm replacing this 10 kilo with that 100 kilo that I showed you before. So let me take out this. It's beeping as long as the LED is staying on. Pretty interesting. So now I changed a tiny little bit the width of the impulse. So now yeah, with the 10 kilo it was too thinner pulse with it, but this is more sharper pulse. This is the maximum. Yeah, very cool. And now, very interesting, if I'm switching from here and when I'm pressing, doesn't matter how long I'm keeping my finger on the button press, nothing will happen there. See? Very cool. Very cool. Very cool. Now for this active beeper that I'm having here, I didn't need that resistor because that resistor from the output was only for the probe. It was interfering somehow, I don't know how, but right now it's not interfering at all. So this is not creating any problems. So it can be linked directly like that, pretty much like in the diagram that I'm having there. Yeah, I'm so sorry. I'm so disappointed that I burned this little fucker. It was small and it was perfect there. Yeah, well, shit happens. And it was a scrap. This is a scrapped element, and I really don't know how to find it and how. Probably it's very expensive as well. Anyway, this is a little bit too big, but at least it's working at 5 volts without complaining, without problems. Directly at 5 volts is very user friendly like this. I will see what I can do. I don't know. Pick. And I really like the sharpness of the sound with this 100 kilo and 1 microfarad that I'm having there. Very cool. I like it. I love it. I'm having a little bit of hiss, but is not a problem. And now if I'm switching, it's doing it by itself. Yeah, very cool. Very cool. All right, this is all that I wanted. Minimal components there. A little bit too big, this one. For this one, for the chip, I will use probably SMD version of this because I only need to use two gates from that, or two small SMD gates like I used already here. I'm not completely sure what I will do, but it's doable. Is I can make it. So this test is telling me yes, you can do it. Yeah, excellent. I love it. All right.